Hello guys, welcome to my YouTube channel. Today I'm going to discuss about sorting array. Let's see the overview. First we're gonna learn about introduction to the sorting. Next types of sortings and applications of sorting. First introduction to the sorting. Sorting is a process of arranging element in a particular order, typically in ascending or descending or based on the criteria. A sorting is a arranging of a number in a order by ascending or descending or according to alphabets, according to the numbers. And sorting is essential for efficient searching, data analysis, and various other operations where having the data in a specific order makes tasks more manageable and faster. Uh, Sorting arranges the data in a order wise like alphabetical order or number order or any another order, which makes the user to access the data more faster. Next, the different types of sorting. First is a bubble sort, next selection sort, and quick sort, and also merge sort. First we're gonna see bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the list to be sorted, compare adjacent elements and swap them if they are in a wrong order. In bubble sort algorithm, the algorithm will compare the adjacent elements, whether it is smaller or greater than the adjacent elements, then it's going to swap. Here is there an example for a bubble sort. In this array we have 5 2 9 1 and 5 6. In this we going to compare 5 and 2, 9 and 1, and 5 and 6. In this 5 and 2, the 2 is lesser than 5, so it's getting swapped. In 9 and 1, 1 is lesser than 9, so 9 and 1 will get swapped. And 5 and 6, actually 5 is lesser and 6 is greater. Here we are going to arrange in a ascending order. So we get array as like this. In next step we get array like this. In this we are compared 2 and 1. 2 is greater and 1 is smaller, so it's get swapped. And next 5 and 5, it's both are equal, so it's be as it is. And 6 and 9, so 6 is lesser and 9 is greater, so it will be as it is. Then finally we get the array as 1 2 5 5 and 6 9, and there will be no swaps. Now bubble sort has a time complexity of 0 n power 2 in the worst case and advantageous case, where n is the number of elements in the list. The worst case and best case possibility of the bubble sort can be defined as O of n power 2. In if we compare in the above example, we have 1 2 3 4 5 6 6 elements. If we put the n value as 6, we get the value as n power 2 36. The worst complexity will be swapping the 36, doing the algorithm, and 36 times, swapping the elements 36 times will be the worst case complexity. It is not very efficient for larger database, but can be useful for small data sets or as an educational example due to the simplicity. Bubble sort cannot be used for a larger data set base, and it is very simple, and there is no complexity in bubble sort. It's very simple, so it cannot be used for larger database. Next we have selection sort. Selection sort is another example for sorting algorithm that works by repeatedly finding the minimum or maximum elements from the unsorted part of the list and moving it to the beginning or end of the sorted part. In bubble sort we are comparing the adjacent elements, but in selection sort we are seeing the minimum or maximum and moving it to the uh, unsorted parts. Let's see the example. In this array we have 64, 34, 25, 12, 22, and 11. This is an array. Here we are comparing that 11 is minimum value is 11. Swap the first element. Next we gonna see which is the another minimum element. Next 12 is the minimum element, so we swap to the second element. And next is 12 is the minimum element, so we gonna swap to 22. 22 is the second. Next we have 22 as the minimum element. Next we gonna swap 22 into the third element place. Next we have next minimum is 25. Next we gonna swap 25 to the fourth element place. Next we have 34 as a minimum element, and it's in the same place, so no need of swapping. And next is 64, it's in the last place, and this is the maximum number, then it's no need of swapping. At last we get the arrays 11, 12, 22, 25, 34 and 64. Selection sort has a time complexity of O of n power 2 in the worst case and average case, where n is the number of elements in the list. Selection sort worst case complexity will be same as the bubble sort. Unlike bubble sort, it is not very efficient for larger database. Same as the bubble sort, it is not used for any larger data transformation or storing. Next we have merge sort. Merge sort is a popular sorting algorithm based on the divide and conquer approaches. It works by dividing the unsorted list into the smaller sublist, sorting each sublist and then merging the sorted sublist back together to obtain the final sorted list. Merge sort is a list which merge sort is used on the divide and conquer approaches. Divide and conquer means dividing the array into two different parts and sorting it differently and merging it again. Let's see the example. In the example, we have a array of 38, 27, 43, 3, 9, 82 and 10. In this we gonna divide the array into two equal halves. Then we get the one array as 38, 27 and 43, and another array as 3, 9, 82 and 10. Now we gonna sort the different two arrays into different. Then by sorting the 38, 27, 43, we get 27, 38, 43. By sorting the 3, 9, 82, 10, we get as 3, 9, 10, 82. Then we gonna merge at step 3. Then we gonna merge 27, 38, 43 and array 3, 9, 10, 82. Then we will get the final array as 3, 9, 10, 27, 38 and 43 and 82. Merge sort has a suitable time complexity of 0 n log n, where n is the number of elements in the list. The best case complexity of the merge sort is derived as 0 n log n. It is an efficient sorting algorithm and is widely used for sorting larger database due to its reliability and performance. Actually, merge sort is not like bubble sort and quick sort, bubble sort and selection sort. It is used for the larger data transitions and storing and sorting the larger datas. Next we have quicksort. Quicksort is a popular and efficient sorting algorithm based on the divide and conquer approach. It works by selecting a pivot element from a list and partitioning the other elements into two sublists. It then recursively sort the two sublists. The process is repeatedly until the entire list is sorted. Quicksort is also like a merge sort. It is based on the divide and conquer approach. In quicksort, we are gonna select the pivot element. Then we're gonna compare the other elements in the array. Let's see the example. In the example, we have an array of 30, 10, 40, 20, 50, 60. Here we're gonna select the pivot element as 60. Then we get the array of 30, 10, 40, 20, 50. In that the pivot element will be 60. Then we're gonna divide the array. We get 30, 10, 40, 20. In this continuous recursively sorting the sublist, left sublist will be 10, 20, and a pivot element in that array list will be 20. In right sublist, the array will be 30, 40. In that the pivot element will be 30. Combining this, then we're gonna sort the array. When we're gonna combine it, it will get as 10, 20, 30, 40 and 50. The pivot element will be 60 and we're gonna add the pivot element also. Then finally we get the sorted list as 10, 20, 30, 40, 50 and 60. Quicksort has the average case time complexity of 0 of n log n, where n is the number of elements in the list. The best case complexity of the quicksort is same as the merge sort. It is derived as the 0 of n log n. In quicksort is generally faster than other sorting algorithm like merge sort or hep sort. In quicksort is the fastest sorting algorithm, is better than the merge sort and other sorts. It is widely used in various programming libraries and applications for its efficiency. It's widely used in libraries and managing the data, arranging the data in big companies and etc. Next, we have the applications of sorting. First, first application is searching. Sorted data allows for efficient searching using binary search or interpolation search. Actually, main sorting is mainly used for searching purposes. It arranges the data in the ascending, descending, or according to alphabetic or number wise and different ways. And next we have database management. Database often store data in stored order based on primary keys or index. This speed up queries and ensure faster retrieval of information. In database management, it is arranged in the according to the user types, like asterisk numbers, and next it will be alphabetical or in MB wise or KB wise or GB wise, and it will be very easy to retrieve the data while it is arranged in a order or sequence. File systems. File systems uses sorting to maintain the directories and files in a well organized manner, making it easier and quicker to access specified files. Uh, in the file management, the file is arranged in the order of KBs, MBs, or in the alphabetical order, or in depending on the priority of the files. It will be arranged in the sequential manner, and it will be used for accessing the file very faster. Task scheduling. Sorting can be used to schedule tasks or processes based on their priority or execution time, ensuring that the most critical tasks are executed first. In task scheduling, it schedules the uh, tasks by where it is more critical or easier. When it shows the easier task first and difficult task as last, or the difficult task as first or easier task as last, it depends on the user which he wants to select. Next, we have ranking and leaderboard. In online gaming and other competitive platform, sorting is used to maintain ranking and leaderboard based on scores or other performance metrics. In games like PUBG and Free Fire, they will be giving the ranking according to word ranking or state ranking or national ranking. In that leaderboard, we're gonna use merge sorting techniques, which gonna sort the players and ranking the 1 2 3 until end, and it's gonna sort very efficiently. And thank you for watching my video.